So today's topic is polar coordinates. Polar coordinates is essentially a different form of. I threw them all away. Yeah.
No homework for me. What?
Print it out yourself online. I am, yes. 25%. There are two ways of doing coordinates. One way is the standard XY form. That's called Cartesian coordinates. Who is it named after?
Descartes.
Rene Descartes. Very good. French philosopher. But polar coordinates are a different way of doing it. So as you guys know, for Cartesian coordinates, a point x comma y is called x comma y because you go x units to the right and then y units upwards. On the other hand, polar coordinates are a totally different schema because instead of thinking about right and left, we're thinking about angles and radius. The good news is that we've already seen this before in vectors. So we start at the positive x-axis, and then we go theta units counterclockwise. And then, based on the direction that we have from there, we go r units out from the origin. And so that's how we get to our point, r comma theta. R represents the radius. So the first number represents the radius, the distance from the origin, and the second number represents the angle that it makes with the positive x-axis in the counterclockwise direction. Any questions?
Question. Can you keep this on here a bit longer so I can write it down?
Sure. So this is very similar to vectors when we thought about magnitude and angle, right? So there shouldn't be anything new here. It's also very similar to complex plane coordinates, complex number coordinates, right? Trigonometric form, exponential form, e to the I theta. So that's the same r and the same theta as in complex numbers. Okay, let's do an example. Suppose we had the polar coordinate 2 comma pi over 6. Okay, so 2 is the radius and pi over 6 is the angle. And so if we were to graph this point, suppose the question asked us to convert this to Cartesian coordinates or rectangular coordinates, we would start at the positive x-axis, then go pi over 6 counterclockwise, 30 degrees. And then we start from the origin and go 2 units in that direction. A little bit. And that would get us to our point 2 comma pi over 6. And so if we wanted to convert this into rectangular coordinates, this would just be 2 cosine pi over 6 comma 2 sine pi over 6. Right? That's just because of the unit circle. So it's the same as for vectors. It's going to be r cosine theta comma r sine theta. That's the general rule. Okay, so the rectangular coordinate would be, right? It would be root 3 comma 1. That would be our Cartesian coordinate. Any questions? So hopefully your trig is good and you'll be able to do this quickly. If your trig is bad, you should review it. So where polar coordinates are not quite the same as vectors is that r can actually be negative. And we'll look at a case where that might be.
Wait, can you go up? You have to convert it to. Oh, yeah.
Yes, so r can be negative. And what do we do when r is negative? When r is negative, instead of going outwards in the same direction as the angle, we go in the opposite direction instead. So if I had negative 2 comma pi over 6 instead, So in this case, my r is -2, right? So instead of going in the pi/6 direction, so I'm still going to figure out where pi/6 is, but instead of going in the positive direction, I'm going to go in the opposite direction now. The direction that is opposite of pi/6. And this would be -2. And so I can still use the same formula. So the rectangular coordinate is still going to be r cosine theta comma r sine theta. So it's still -2 cosine pi/6 comma -2 sine pi/6. But as you can see, that's going to give me a Cartesian coordinate that's in the opposite quadrant. And so my answer is going to be -√3 comma -1 instead. Okay, so when r is negative, you go in the opposite direction of the positive direction. Any questions?
Would it also be written as, no cosine 7 pi/6?
Yes, that would be the same point.
So that's.
So the same, yes, the same point can have different representations in polar coordinates, unlike Cartesian coordinates, which are unique. Okay, let me do another example just for fun. Let's say we have both a -r and a negative angle. So maybe -5 comma -5 pi/4. All right, so I'll go through this. The first step is to find where the angle is. What quadrant is -5 pi/4? 2, very good.
-5 pi. Oh, you're right.
Right, -5 pi/4, we have to go clockwise 5 pi/4. So that's going to bring us to this direction, right?
That's like at the end it was in fourth quadrant.
Sure,
Last step.
sure, whatever you say. And then we go, so if r were positive, we would go in this direction, right? But since r is -5, we're going to go in the opposite direction, which is this direction. And so we're looking at a point that's 5 units away from the origin in the fourth quadrant now. Okay? And so to find the rectangular coordinates, you can either do like r cosine theta, r sine theta, or you can just look at this point and you know this is a 45-degree angle, right? And then you can kind of extrapolate what the coordinates are based on where it is in the quadrant. And so the answer would be 5√2/2 comma -5√2/2. Okay. Any questions?
Wait, can we do it? Stop. No.
Blue tells you the angle, red tells you the radius here.
So cosine with all. This is cosine.
What?
Like we're going off of like this line right here. Like this course.
Yes, that's the point we're looking for. Yeah, cosine's positive there. But r is also negative, so negative.
So now,
Yes,
why is there 45 degrees in there? No,
why?
I thought you said we weren't allowed to use degrees ever again. It's like,
Didn't we use degrees in the vectors unit? Any questions? Do you guys want to work on the classwork or should I finish the lecture?
finish the like,
Okay, you guys might get lost, but okay, let me keep going. Sometimes you also have to go from rectangular to polar, okay? Rectangular to polar. It's very similar to complex numbers where you had to go from trigonometric to standard and standard to trigonometric. And it's the same exact math going on. So for instance, sometimes you might have a rectangular coordinate of like 1 comma negative root 3. Will that overlap with the classwork? Hopefully not. Did not. Okay. And so it's very straightforward to go to polar coordinates. You just plot it on the plane and you figure out which quadrant it's in, what's the radius, what angle it makes with the positive x-axis, right? So 1 comma negative root 3 is somewhere here, right? Root 3 is longer than 1, so we know it should be, the angle is going to be, what is that? 4 pi over 3? Long pause. Okay, so the angle is 4 pi over 3, and the radius is 2, right? And so from this, we could conclude that the polar representation would be 2 comma 4 pi over 3. Got the radius because it's just x squared plus y squared square root, right? Pythagorean theorem. So it's 1 squared plus root 3 squared square root, which is 2. Any questions? Now, as I said before, polar representations of coordinates are not unique. And so this could have also been 2 comma negative pi. Wait, this is totally wrong. Nobody corrected me. Right, this is 5 pi over 3. You guys are not paying attention.
Mhm.
5 pi over 3, which means the angle could have also been negative pi over 3, correct? And so these would represent the same thing. Can anybody come up with another one?
11 pi over 3.
Okay, but that's too straightforward. It could also have been negative 2 pi over 3. Right? Because 2 pi over 3 is in this direction, and we could have just had a negative radius to bring us to 2.
Negative 2 comma 8 pi over 3.
Sure.
And negative 2 comma 16 pi over 3.
Any questions?
Doesn't matter which one.
Choose the simplest so it's easier for me to grade. Or this one, 2 pi over 3?
Radius.
The radius here is positive if I have an angle of 5 pi over 3.
Which are going in the same direction.
Yes. Any other questions? All right, let me talk about the very final section because I want to get this over with. Which is converting from rectangular to polar equations. Rectangular to polar equations. Okay. So the general rule for converting from rectangular to polar is that we just need to make 2 simple substitutions. We just need to make the substitution x equals r cosine theta and y equals r sine theta. You guys understand why these substitutions should be made?
Do not just do this rectangular to polar.
It's equations now.
Oh, okay.
So we just make those substitutions, and then that will help us to convert an equation from xy to r theta, which is our goal. Our goal is to have no more x's and no more y's, and only r's and thetas. So I could do an example. We might have, let's say we had a straight line, okay? Y equals x. So we all know what this looks like. This is a straight line that goes through the origin, slope 1. So how do we convert this to a polar equation? Well, we just make the substitution y equals r sine theta. So it's r sine theta equals x, which is r cosine theta. And then generally we want to make everything on one side. And so we can divide both sides by r and also divide both sides by cosine. And that would give us tangent theta equals 1. And then we should simplify and go further. And we could say theta equals pi over 4. And so that would be our polar equation. And you can confirm this with the graph, right? Every single polar coordinate that has theta equals pi over 4 can be found along this line because this angle is pi over 4. Right? And so indeed, this is the same exact equation as y equals x. Any questions? I'll do another example. Let's say we had the graph 2x. No, let's do another line maybe. Let's say we had y equals 5, okay? So that's a horizontal line going through the point 0, 5. How do we convert this to polar coordinates? Well, we just make the substitution y equals r sine theta. So we have r sine theta equals 5. And then we'll try to isolate, each variable to each side, divide both sides by sine theta, which gives us 5 cosecant theta. And that would be our polar equation. And the graph of this polar equation would just be y equals 5. Okay. Now, another very important fact is that x squared plus y squared equals r squared. And the reason for why this is quite straightforward. That's because x is equal to r cosine theta, and so x squared is r squared cosine squared. Y is r sine theta, and so y squared is r squared sine squared. And then if you just factor the r squared out, you're going to get cosine squared plus sine squared, which is just 1 based on the trig identity. And so you end up with r squared. And so that's another substitution that you can make, which would help you with 3a probably. But that concludes my lecture.